friends, in the previous video we have discussed number system. Now in this video we are going to discuss Euclid's division lemma. Now Euclid was a great mathematician of all times. He has introduced many things in the field of mathematics. You have already learned Euclid's geometry. Now this particular lemma means it's a proven statement only. This particular lemma was introduced by Euclid, the mathematician Euclid. That's why this is known as Euclid's division lemma. Let us see what is this Euclid's division lemma. First, let us choose any two positive integers. For example, I am taking the positive integers as 19 and 5. Two positive integers where we know that 19 is greater than 5. Let us divide 19 by 5. So when we divide 19 by 5, we get 3 as the quotient, 3 5s are 15 and 4 as the remainder. And we know that dividend is equal to divisor multiplied by quotient plus remainder. So we can write it as 19 is equal to 5, the divisor multiplied by the quotient 3 plus the remainder 4. Now, Euclid's division lemma says that this remainder or the value of the remainder depends upon the value of the divisor. Let us see how. Instead of 19, now I am taking 15 and divisor the same 5. So we know that 15 is equal to 5 times 3 plus 0, no remainder. If we take it as 16, 16 is equal to 5 times 3 plus 1. 17 is equal to 5 times 3 plus 2. 18 is equal to 5 times 3 plus 3. 19, already we have written, is equal to 5 times 3 plus 4. Now 20 will be equal to 5 times 4. No remainder, that is 0. If we move further, 21 will be equal to 5 times 4 plus 1. 22 will be equal to 5 times 4 plus 2 and so on. Let's just check the remainders. Remainders are coming 0, 1, 2, 3 and 4. Again 0 comes, next will be 1, next will be 2, 3, 4, again 0, 1, 2, 3, 4, etc. So if we divide by 5 or if we take the divisor as 5, the possible remainders are 0, 1, 2, 3 and 4. That is why we said the value of the remainder depends upon the value of the divisor. So if we are taking the divisor as 3, then the values of the remainder will be 0, 1 and 2. If we take this divisor as 6, then the values of the remainder will be 0, 1, 2, 3, 4 and 5. One less than that of the divisor. So this is actually Euclid's division lemma. If we state it in the form of a lemma, we can take this 19 as A, this divisor as B, this quotient as Q, remainder as R, then we can write as A is equal to BQ plus R, B multiplied by Q plus R, where the most important thing is the value of the remainder, that is 0 less than or equal to R less than B. That means 1 less than that of B, starting from 0. For any two positive integers A and B, there exists positive integers q and r such that a can be written as a is equal to bq plus r, comma 0 less than or equal to r less than b. This statement is known as Euclid's division lemma. So, hope it is clear for you. Now, let us see few examples using this lemma. You have one particular question in the textbook, first exercise. The square of any positive integer can be written of the form 3m or 3m plus 1. The question is, show that the square of any positive integer can be written in the form 3m or 3m plus 1. 3m means a multiple of 3 or it may be a multiple of 3 plus 1. If we need to show this, we are not supposed to take any particular example or few examples of integers, square it, and whether we are able to write them in the form 3q or 3q plus 1, something like that. Whenever we get a question like this, we need to take general statements only or general proof only. We can take, let a be any positive integer. Let a be any positive integer. And we have the statement a is equal to bq plus r. This divisor b, you take it as 3 because the question, it is mentioned either of the form 3m or of the form 3m plus 1. That is why we are taking b as 3. So, this can be written as a is equal to, now we are taking b as 3 in that particular question. So, it will be 3q plus r where 0 less than or equal to r less than 3. That means r is equal to 0, 1 or these are the possible values of the remainder. So, if we are putting r is equal to 0, we get a is equal to 3q plus 0 or simply 3. If we are putting r is equal to 1, we get a is equal to 3q plus 1. If we are putting r is equal to 2, we get a equal to 3q plus 2. So these are the possibilities. Now take the square because the question is about the square of the positive integer. So if a is equal to 3q, then a square will be equal to 9q square. A square will be equal to 9q square. That means 3 times 3q square, which is of the form 3m, a multiple of 3, that's all. Second, a is equal to 3q plus 1. So if we take a is equal to 3q plus 1, that means a square will be equal to 3q plus 1 the whole square. 3q plus 1 the whole square means a plus b whole square format. So a square plus 2ab plus b square, that is 9q square plus 6q plus 1. Now this put in a bracket. 3 is common. So we can take it as 3 times 3q square plus 2q. Close the bracket plus 1. Now this you take it as any m or n, whatever you want. So this is of the form 3m plus 1, that is a multiple of 3 plus 1. Now the last one, if we are taking or if a is of the form 3q plus 2, that implies a square will be equal to, again, a plus b whole square format, a square, that is 9q square plus 2ab, 2 3s are 6, 6 2s are 12, 12q plus b square, that is 4, which implies this 4 can be written as 3 plus 1. So 9q square plus 12q plus 3 plus 1. Now this much put in a bracket. check each and every term is divisible by 3. So take 3 outside, that is 3 into 3q square plus 4q plus 1, close the bracket, plus 1, which means again 3m or 3n plus 1. So a multiple of 3 plus 1. So this is the proof of that particular statement, that is any positive integer, the square of that is either of the form 3m or 3m plus 1. Similarly, there is another question. The cube of any positive integer is either of the form 9m or 9m plus 1 or 9m plus 8. There also you can do the same thing, but no need to take b is equal to 9, because the question is about the cube. So you can take b is equal to 3 only, because we know what is a plus b whole cube. So just think about that and take the value of b. So you just take b is equal to 3 and write the same thing, a is equal to 3q plus r, the variation of r, and take the cube. Find out the value of a cube and check whether you are able to write them in the form a multiple of 9, that is 9m, and a multiple of 9 plus 1, that is 9m plus 1, or in the form 9m plus 8. So this is all about Euclid's division lemma. Hope it is clear for you. Now the next is Euclid's division algorithm to find the HCF of two numbers, that we will discuss in the next video. Thank you.